Now, we've defined what we mean by an expression, an equation, a formula, and an identity. But what about inequalities? Well, inequalities are usually quite easy to spot because there's no way of really getting them mixed up with any of these four. Because essentially an inequality has to have an inequality symbol in it. So, for example, x is less than 3, or x is less than or equal to 3, or x is greater than 3, or x is greater than or equal to 3. If it's got any of those four symbols in it, then it has to be an inequality. Okay, so you can also have double inequalities, of course. So you could have, we've seen this before, so something like 3 is less than x is less than 5, which, and the way that you read it is from the middle outwards. So x is greater than 3, but less than or equal to 5. So if you had this, x is greater than 3, but less than or equal to 5. Or x is greater than or equal to 3, but less than or equal to 5. Okay? So you can have double inequalities, you could have triple inequalities. There's nothing wrong with saying that 2 is less than 3, is less than 4, is less than 5. Okay, so there's nothing wrong with that statement. How useful statements and inequalities to solve can be with that, with several stages, really depends on the problem. But it's unlikely you'll see anything beyond double inequalities like this. Now, inequalities can be solved just like equations. So if you had x plus 1 is greater than or equal to 5, then it stands to reason that x must be greater than or equal to 4. Okay, so you can solve inequalities. We'll be doing some of that later on as well. But it's really here is just to make sure you can identify that anything with one of these inequality symbols must be an inequality.